Hi, my name is Keith Wildhaber. I'm a service advisor with G.A. Larson. We're going to talk about A2L refrigerants and how these changes are going to affect you and your company. So, first thing everyone wants to know is why are we making these changes? Well, back in 2021, part of the Inflation Reduction Act that was passed was the AIM Act, and this included a clause about low GWP refrigerants being required that have a global warming potential of no more than 700. We'll define what that 700 and that GWP actually is in a little bit. Predominantly in air conditioning systems for residential use, we're going to be talking about refrigerants R454B and R32. Now, A2L refrigerants are slightly flammable, and a lot of people are under the impression that they actually contain propane, which they do not. So we'll probably put that myth away right off. Now, because of all the changes, safety is a concern. Obviously, performance, we want the equipment to do what it's designed for, and the environment, the predominant reason we're making the changes. Because of that, many people are involved. UL wants to be involved because we're making significant changes to the equipment. ASHRAE wants to make sure that the equipment actually performs and is efficient. The EPA, AHRI, National Fire Protection, Department of Transportation, manufacturers, and others. So really, since this was mandated back in 2021 to implementation now in 2025, this has all taken place in a very short amount of time. And as you can see, a lot of people had to get together to make these new rules. So let's start off with a little history lesson about refrigerants. R22, this was the old standby refrigerant for residential use, had an ozone depletion of about 0.05 and a global warming potential of 1,810. Now, the ozone depletion level was what caused a lot of concern and why we switched over to R410A. R410A had an ozone depletion of 0, but it also had a global warming potential of 2,088, which is now why we're switching to the R454B and R32. R454B has an ozone depletion level of 0 and a global warming potential of 466. Another thing to think about, or that we'll have to talk about, is air refrigerant's density compared to air. So, do they have a tendency to sink or rise in a still airspace? Well, natural gas, which is a fuel, actually has a density of about 0.6, so it would have a tendency to float to the top of a room in a still airspace. Both R32 and 454B is about 2 times heavier than air, but with normal air currents can quickly get mixed around. Now, R410A actually was about 50% R32 and 50% R125. You may be asking yourself, why didn't we have all these flammability concerns with R410A? Well, the R125 in this mixture is actually used in high-end fire suppression systems. Things that would be used for museums or places where water may do as much damage as the actual fire. Because of that mixture, it kind of negated the flammability aspects of R32. R454B, which is also a blended refrigerant, is about 69% R32 and 31% R1234YF. Now, if that R1234YF actually sounds familiar, that's actually a refrigerant that is used almost exclusively in the automotive field. Now, the global warming potential, what does that actually mean? Well, it's basically a substance's or molecule's ability to absorb and retain heat when it's released into the atmosphere. Lower GWP refrigerants actually break down more rapidly. Many of the HCFCs that we were used to had lifespans when released into the atmosphere measured in years, whereas the newer A2L refrigerants break down in a matter of weeks. Now, that global warming potential, that's actually referenced off of carbon dioxide. Carbon dioxide is our baseline that has a global warming potential of 1. So you can kind of see how some of the R410A, for instance, held a lot more heat than carbon dioxide molecules in the atmosphere. Now, you may also come across documents there where HRI had listed or mentioned 750 as the maximum allowable GWP. However, the EPA actually altered this down to 700 after that information was published. So it's not that it was an error, it was just published before that change was made. 700 is the maximum allowed GWP as of January 1st, 2025. And as you can see, R32 actually has a GWP of 675, below that 700 line. R454B is even further below that line with a GWP of 466. Now, there is mention and rumors of that GWP being lowered to a maximum of 500 in the year 2030. If that does come to pass, R32 may have to be reevaluated if it can be utilized. When we're talking about classifications of refrigerants, we used to have just A3 and B3, the A and B2s, the A1 and B1s. The A's actually refer to the refrigerant's toxicity level. The higher toxicity were the B-listed ones. The 3, 2, and 1 are the flammability levels, 1 being no flame propagation, and 2 being flammable. Well, with the low flammability refrigerants that we're looking at now, they didn't really fit the criteria of being an actual flammable refrigerant. So in order to make them fit the designation they're getting, they actually listed a new designation, the lower flammability limit, or the A2L and B2L refrigerants that we're talking about today. When we're talking about flammability concerns, we're basically speaking of three different aspects. One, the concentrations at which point that mixture becomes flammable when mixed with air, how much energy it actually takes to ignite, and the speed of that flame propagation, or how fast that flame would travel through a mixture of flammable refrigerant. Now, if you're talking about propane, which propane is a refrigerant, it's R290. It has a lower flammability limit of 2%. So a mixture of air with containing 2% propane would be able to be ignited. R32's lower flammability limit is 14.4%, and 454B has a lower flammability limit of 11.8. Now, many of these also have an upper flammability limit. So once they exceed this ratio or percentage when mixed with air, they can no longer be ignited either. And as you can see, both R32 and R454B have a relatively narrow range where they are in a flammable mixture with air. Another aspect we're speaking of is the amount of energy it actually takes to ignite that perfectly mixed flammable mixture of air and this refrigerant. With propane, it would take about 1 millijoule of energy. Now, a millijoule of energy, it's basically how much energy you have to input to get it to ignite. A typical spark plug puts out between 20 and 30 millijoules of energy. As you can see, it doesn't take a lot to light off propane. With R32, it takes about everything a standard spark plug could put out. And with R454B, it would actually take over 100 millijoules, or basically about everything between 3 to 4 spark plugs could put out in order to light that mixture. Another point of reference. When you're talking about the flammability, one of the more flammable items we deal with in the HVAC industry is acetylene. Acetylene is way down here in the bottom left corner. The horizontal scale is actually the flammability limit, or how much of a percentage when mixed with air, where it has to be in a flammable mixture. This vertical axis actually refers to how much energy it takes to ignite that mixture. As you can see, R32 is fairly far away from that when you consider gasoline is over here, as well as methane, isobutane, ammonia. Many things are much easier to ignite than these A2L refrigerants. And R454B is actually harder yet to ignite. So hopefully this is starting to relieve some of those concerns you may have about just how flammable this refrigerant is. When we talk about putting energy into it to ignite it, propane, when ignited, actually burns at about 18 inches per second. So this would be its flame propagation speed. And we're used to seeing this in many furnaces. When the igniter lights off the flame travels across to the other burners at about 18 inches per second. With R32, that speed is down to around 2.5 inches per second, much slower than it is with propane. And with R454B, slightly slower yet, about 2 inches per second. So it's actually a very slow traveling flame. In this slide, you're going to see that there's a tube of perfect mixture of air and an A2L refrigerant. And you can see how slowly that flame travels through that tube. If we were to do this with something like propane, it probably wouldn't be a tube left or a test chamber. So again, not going to travel all that fast through a flammable mixture. Now, one of the other things we have to be concerned about, though, is not just us working with it, but how this slightly flammable refrigerant is going to affect others when they come in contact with it when working. People like firemen and other emergency personnel. So, what's changing in order to meet some of those concerns? Well, first off, you're going to see tags on the new equipment that contains an A2L refrigerant, indicating that it is flammable. If they don't come already attached to the coil, you want to put them in place. You don't want to be the one shifting liability onto yourself or your company. You'll also see these plastic tags at the service ports. After you braze in the equipment, which they should be removed while doing that, and then replaced once that is done. You'll also notice that the service ports are very similar. In fact, they're the exact same as they've always been. They're right-hand threads, and the gauges and hoses that you currently have for working on a system can connect to these as well. Now, one of UL's requirements is that the caps be locking. Now, this isn't building code standards. This is UL standards. UL requires or considers it locking if a tool is needed to remove that. A wrench is a tool. And if you're working on a heat pump, those service ports are actually behind a panel that requires a nut driver to remove that panel. So if your local code actually requires a keyed locking cap, that will take precedence over this. Now, R410A in comparison to R454B and R32. Well, R454B is going to travel at about 10% slower speed through the refrigerant lines. R32 is actually going to travel at about 20% slower speeds. This is going to affect refrigerant oil return, as well as other factors in our system. So you will see smaller lines in order to keep those speeds high enough in order to return that refrigerant oil back to the compressor where it's needed. Because of that, we're also going to try to hold about 10% less refrigerant charge in the system, which also helps with the flammability concerns. R454B discharge line temperatures from the compressor are going to be slightly higher than 410A. 410A, we expected the discharge from the compressor to be approximately 60 degrees above the outdoor ambient temperature, and 454B is going to be very similar to this. With R32, we're going to see it about 20 degrees or about 80 degrees higher than outdoor ambient, 20 degrees above those 410A temperatures. High pressure cutoffs, predominantly such as train equipment, we had a 650 psi high pressure cutoff on the equipment. This is going to be changing to 600. We're going to use similar compressor oils with 454B. With R32, it is going to be using a slightly heavier oils simply because R32 has a little bit more of a solvent action. The deadline for installation of 410A equipment, which is being phased out, will have to be installed for new systems no later than December 31st, 2025. And self-contained equipment will extend until December 31st, 2027. Now, the equipment can't be manufactured for new installations after December 31st, 2024. So basically, this means we have a one year sell-through period for split system air conditioners before they can no longer be installed. You'll also notice tags like this on the outdoor equipment, and you'll need to fill them out on every installation. The information you need to add to it is how much is charged from the factory, or what's contained in the unit when you first receive it, how much charge you added once you installed it for the appropriate line set and indoor coil, and then the total system charge. Add to that your dealer name and your dealer phone number. This needs to be filled out on every installation. All of the refrigerant tanks are going to have a red band or a red top. Both charging tanks and recovery tanks are going to have left-hand threads. Now, to make sure that you can still attach to it with your gauges, this is going to require a left to right thread adapter, such as the JBQC A2L-LH or the Fieldpiece HR1XR. These fittings are available at our various branches. Make sure you pick one up before you leave with a tank. You'd hate to drive 2 hours away only to find out you can't attach to the tank to properly charge the system. Now remember, this is only the tanks. The actual service ports on the equipment will still be right-hand thread, just like they've always been. I always recommend get 2 of these fittings though. One to use, one to lose. The refrigerant cylinders themselves will have a couple of changes. With our 410A and other refrigerants, we always had a burst disc. So if that tank overpressurized, that burst disc would open and release the entire refrigerant charge. Because of the slightly flammable characteristics of the A2L refrigerants, we only want to release enough refrigerant to bring that pressure down to a safe operating pressure for that tank if that tank becomes overheated or overpressurized. So these will have actually a relief valve, which will reseal once that initial charge was released in order to bring that pressure down. Now we only want to relieve enough refrigerant in order to bring that pressure down, so we want to relieve it as a gas. Therefore, these valves should be on the upper side of the tank where it will release a vapor versus in a lower part of the tank where it would release a liquid. So when storing these tanks in your truck or in your shop, these valves need to be on the upper side of the tank. These are non-refillable refillable cylinders. The storage tanks for the storage temperatures for these tanks is no more than 125 degrees Fahrenheit. This is where the design working pressure is. That does not mean that the tank is going to burst at that level. Basically, they shouldn't burst until they at least exceed that by 2 times. When we're talking about storing it, initially there was some talk about adding vents to trucks or requiring to add vented trucks in order to haul this refrigerant around or have it on the truck. That idea is recommended, but it is not required. You will be able to have at least 6 or up to 6 of these 25-pound cylinders on your truck. Now, if you're doing the large commercial refrigerant tanks, then you can only have 1 of those 220-pound tanks. 6 25-pound tanks actually goes pretty quick when you consider 1 partial and 1 full of 454B and then a recovery tank as well. And then also probably for many service people, you'll also have a full and a partial tank of R32 and a recovery tank for that as well. So these 6 tanks can get used up very quickly. Just like we always have had, we don't want to mix these refrigerants, so do separate them. Now, refrigerant lines and tools that you're going to be needing. Well, our line sets are actually going to get a little bit smaller. You'll see that our 2-ton, our service valve size are going to be 1/2 inch for vapor and 5/16 for our liquid. For the 3-ton, they'll be 5/8 and 5/16. And as you'll see, all of these have a 5/16 liquid line. That's the service valve connection. And what it's rated with is 5/16 liquid line. But there are many alternate line sizes. Yes, you can still work with a system that has a 3/8 liquid line. You may notice that some of the vapor lines get slightly smaller, and there is no 1 1/8 vapor line any longer. This may also affect our maximum line set length as well as lift. Make sure you consult that installation manual and to make sure you have an approved alternate line set size. For connecting our line set, we can utilize flares, pipe press, or compression fittings, as well as brazing. We cannot use soft solder, and that practice was abandoned years ago. But if you still are, it is not allowed with R410A or R454B or R32. So make sure you're using actual braze. As far as installing in a house, there are many other changes that are taking place, and most of these are referred to or standardized in the ASHRAE document. It is available for download if you choose to, and that 15.2-2022 would be the document that you would be looking for. Some of the high points of that, though, are pipe protection. We don't want to see the pipes get ruptured. So if you're going through framing members of a home, and you're within 1.5 inches of the edge of that framing member, they're going to require nail plates. Now, those have been used for many years when it came regards to plumbing as well as electrical. So now we're going to come under that same requirement. If it's exposed in a building, such as in a basement, in living space, if it's not above 7 foot 3 inches from the floor, it's going to need to be cased in, such as in line height or whatever your local code requirements dictate. In an attic or a crawl space, again, we just don't want it to be within distance where a sheetrock nail could penetrate the piping. Exterior pipe must be protected from corrosion, degradation, and abrasion. So they have to be secured so they don't rub or contact the building materials where it could adversely affect the piping and create a hole. Now, because they must be secured, obviously this picture would not meet those standards. Line sets must be accessible for inspection. Now, a lot of people have a lot of concern about this, especially if they're trying to reutilize a line set in a finished basement. This will be up to a lot of interpretation by your local building inspector. My recommendation would be have a conversation beforehand. That way, when it comes to speaking with the homeowner, you aren't unnecessarily cutting excess holes in their ceiling, nor are you giving them the impression that you won't have to cut any if your code inspector actually requires you to make more access for them to see it. That conversation ahead of time can be a lot easier before you have to cut the holes than once the inspector actually requires it. Another change that's happening, all the outdoor units or condensers, which you may know them as, are going to be listed for outdoor use only. Now, in the picture you see on the left, that's actually not outdoors. So that wouldn't be acceptable with any of the A2L refrigerants. Other applications where you may have seen condensers placed on a mezzanine level or in a warehouse when part of the building was used for offices would also not be acceptable. Make sure you're looking at that when you're quoting the equipment so that you don't get a surprise and have to move the equipment to meet your local code standards. When it comes to vacuum pumps and recovery machines, The motor is going to have to be spark proof. So DC spark proof motors. Just make sure they're UL listed for working with A2L refrigerants, and it shouldn't be a problem. As far as your gauges, there's really no difference on your gauges. If you have digital gauges, they may need a firmware upgrade. Other than that, a PSI is still a PSI. But if you like to have that P&T chart referenced on the front of the gauge of your analog gauges, there'll soon be ones coming out that have that built into them. A lot of people have pointed out that, hey, you see contactors open and close, and there's a spark that happens there. Isn't that a concern? Well, as long as those electronic components are enclosed in an A2L approved enclosure on the equipment, it's not an issue. They've already looked at that and thought of it. And the ones on the equipment that have A2L refrigerant, they've already been spec'd for that and have met those requirements. Another question people have had is, what about my EPA license? Well, if you have like a Type 2 EPA certification, you're already qualified or licensed to work with even the A2 and A3 refrigerants. So the A2L is no different. You're already qualified. Don't fall victim to the scams out there asking you to take some course online and pay them $50 just so they can give you a piece of paper that means absolutely nothing. When working with the system, all the best practices still apply. Recover or pump down the system, evacuate the system, purge that circuit with an inert gas. Continuously flush or purge with an inert gas while you're using a flame for brazing it in. And anytime you have a flame lit, you should always have a fire extinguisher nearby. Components such as compressors, liquid line dryers, TXVs, and other metering devices, they should not be unbrazed but cut out for safety. In order to flush that line set out, we want to flush at least 5 times that volume through those line sets in order to make sure there's no flammable vapor left in those line sets before we strike a torch to them. Now, they give you a chart here. Basically, if you're purging those line sets with 15 cubic feet per hour, if you have a 50-foot line set, it would take about 2 minutes before it's safe to light a flame to it. Obviously, if you were running 30 cubic feet per hour through that line set, you need to purge it for at least 1 minute before it's safe. And as the line sets are longer, obviously that time goes up. After you've brazed in your new refrigerant line set, you need to pressurize it. Make sure there are no leaks. Basically, manufacturers want you to take that pressure up to 600 psi on the line set and the indoor coil. And then you're going to use soap and bubbles to check for leaks at any field installed joints. Initially, they were going to put the 600 psi on the outdoor unit. However, there were some concerns with that. They don't actually want you to pressurize the outdoor unit itself to more than 450 psi, 480 being the absolute maximum. Beyond these pressures, we can actually distort the housing of the compressor shell, which can affect the shaft alignment inside the compressor and cause compressor failure due to bearing alignment. So while that 600 psi is actual and valid for the line set and coil, if you're pressurizing the compressor or outdoor coil, such as when replacing a compressor or a reversing valve, do not exceed 480 psi. Now, they're actually going to list 100. They're actually going to list 450 on the outdoor data plate. Once you've pressurized your outdoor unit or your line set and coil, they still want you to pressure test 150 psi and then 480 to the outdoor unit. Do not follow the 600 psi that's on the unit when replacing the compressor. Now, what that looks like is, in the diagram here, you can see for the line set and coil, we should pressurize to no more than 600 psi. But if we're pressurizing that outdoor unit again, we're not wanting to exceed 480, and it's going to have a test pressure of 450 listed on the unit. And here you can see an example of that, what that nameplate is going to look like. Once we've assured there are no leaks in the line set or any field installed joints, now we're going to evacuate the system to remove any moisture from the system. We want to vacuum down to 350 microns. And then we want to do a 10-minute rise test. It should not rise above 1500 microns in 10 minutes. This indicates that your system is dry and free of moisture. If it does exceed that after 10 minutes, you need to re-engage that vacuum pump and further evacuate the system. Once you've assured the system is dry and fully evacuated, now you can release the refrigerant into the line set and indoor coil. After doing so, you're going to go around with a A2L certified refrigerant leak sensor. These sensors have to have a sensitivity where they can detect a leak as little as 5 grams per year. There are other components within the mechanical room that you may need to pay attention to. If your water heater is within the mechanical room or the same sharing the space with that A2L refrigerant equipment, your water heater, if it's a gas water heater, has to have a flammable vapor resistant ignition system. All water heaters after 2005, no matter the size, should be FVIR compliant. And 30, 40, and 50-gallon water heaters were made compliant in 2003. Keep this in mind. This also applies to things like standing pilot furnaces. So again, it's easier to be aware of this requirement beforehand when you're quoting the equipment change so that you can meet code requirements once you're finished. You'd hate to have to come back and tell a customer, now we have to replace your water heater. So some different characteristics of these A2L refrigerants. R32 is actually a single component refrigerant, much like R22, so it can be charged as a gas or as a liquid. R454B is a blended refrigerant, just like 410A, and has to be charged as a liquid so that we don't disturb the proportion rates in the refrigerant. Because it's a blended refrigerant, one component of that refrigerant will boil off at a slightly different rate than the other component. Now, with 410A, we basically ignored this fact. Because the glide of that refrigerant was less than a half a degree, so we didn't pay a whole lot of attention to it. With R454B, that glide is a little more prominent, and now we need to actually pay attention to it to make sure we do things correctly. Now, you may not be familiar with glide, so let's take a little time and talk about what that is. But like I said, with 454B, glide is about 10 psi, whereas with R410A, that was about a 1 psi glide, equaling about 2.5 degrees on that 454B. What that glide is as your refrigerant travels through your outdoor condenser coil, for instance, comes out of your compressor as a superheated high-pressure gas, but as it travels through the condenser coil getting subcooled, component A of that refrigerant would actually cool down and turn to a liquid first, while component B is still in a vapor state. Then as it travels further through the coil, component B gets condensed to a liquid. Once both components are in a liquid state, now we can further cool it and start to accumulate subcooling. Going through the indoor coil, it gets boiled off into a gas, and component B would actually boil off first, while component A remained as a liquid. Then, once component A also boiled off into a gas, now we can start to build superheat once both are in a vapor state. Now, there are some different kinds of charts to help you show this to you. This would be R22, a single component refrigerant. And as you can see, both sides are everything changes from a liquid to a gas at a single temperature. With R410A, there was a slight deviation between the two components. This is what your glide is, and it was about 0.3 degrees. With R454B, this glide is extended to about 2.5 degrees. And if you work in the refrigeration systems, you might be familiar with R407C, which had a glide of about 10 degrees, much more significant. This is why you will see both a dew point and a bubble point for your various pressures on your P&T chart. Now, I'm going to continue to help you make sense of this. But basically, when we're talking about superheat, we want to refer to the dew point of that refrigerant. And when we're talking about subcooling a refrigerant, we want to refer to the bubble point of that refrigerant. So, here we have a refrigerant at 100 psi as well as at 300 psi. Basically, our bubble point at 100 psi would be 34.26 degrees. Our dew point, though, would be 36.59. And at 300 psi, as you'd expect, that would change the saturation point. Our bubble point's now 99.8, and our dew point's 102.1. Anything below that bubble point, everything is liquid, and now we can start measuring subcooling from that point. Whereas if it is above the dew point, now we can start adding superheat to our refrigerant. Anything in between those two temperatures, though, your refrigerant's actually a mix of vapor and liquid. So here's a real-world example you may see. I hook up my gauges, and I see 100 psi on the low side, 300 psi on the high side. I have a suction line temperature of 52 degrees and a liquid line temperature measured at 94 degrees. By referring to my chart, it would be very easy to get to the wrong superheat measurement. But if I pay attention to the liquid being off of the saturated liquid temperature, I can see that my saturated liquid temperature is 36. So my superheat, my saturated vapor temperature would be 36 degrees, which is where I can start to build superheat anywhere past there. So at 52 degrees, I can see my suction line saturated temp is 36, my actual line temp being at 52, my superheat is 16 degrees. Now on my liquid side, I need to pay attention to the liquid pressure. And here at 94 degrees for a line temp at 300 psi, I can see that my saturated liquid temperature is at 99 degrees, giving me a subcooling of 5 degrees. Now, if I looked at the wrong column, I could easily think that I was within charging guidelines. However, when I referred it off of my actual liquid line temp saturation temperature, I'd find that my targets were off, and I've incorrectly charged the system. Many of your digital gauges will do this automatically. There are a lot of phone apps, including the Trained Diagnostic Technician mobile app, where you can put these numbers in, and it can help you get to the right conclusion, especially when you're new with this new refrigerant. Similar to 410A, with 454B, minor top-offs in refrigerant charge is perfectly acceptable. If you do have to pull the charge, New refrigerant should be used and basically replenished with small. Similar practices with 410A that we have with 454B. For minor leaks, topping off the charge is perfectly acceptable. But if you've had to charge more than about 35% to your system, you probably no longer have a pure refrigerant. You need to consider removing the entire charge and recharge it with fresh refrigerant, just so that you're not disturbing the balance of those refrigerant charge percentages. So if you've had multiple gas and goes, it's probably time to remove the entire charge and start over. Now we're going to begin talking about mitigation. Mitigation is no more than what do we do if there's a leak and how do we mitigate it? So the goal of any mitigation system is quite simple. If a leak is detected, turn on the indoor blower to circulate the air at the cooling speed to minimize the risk of the refrigerant pooling and reaching those lower flammability limits. We also want to shut down the compressor operation. Turn off any accessories such as electronic air cleaners that could potentially ignite that slightly flammable refrigerant. We're also going to close the alarm contacts. Once the mitigation event clears and it's no longer sensing that refrigerant at those levels, we can return to normal operation. These are not going to cause a hard lockout for the system. UL approved indoor heat, such as electric heat strips, or the surface of the heat exchanger in a gas furnace, is not high enough to where it has to require mitigation and disable those devices. Any mitigation must trigger before that refrigerant level reaches 25% of that lower flammability limit. Any system that has more than 4 pounds of refrigerant is required to have mitigation. Therefore, you may see some small package units that do not require enough refrigerant to actually have to have a mitigation system. However, because if you're doing a split system, we don't know what size or how long a line set you're putting on, or what size indoor coil is going to be added to the system. So all split systems will have this mitigation system. As far as dispersing the refrigerant, we need to have an adequate amount of air to where we can mix this slightly flammable refrigerant into in order to keep it below those lower flammability limits. Basically, any area of the home that is served by that system's ductwork, both return and supply, can be counted towards that mitigation area or volume of air that we're mixing that refrigerant into. Because of that, there may be some stipulations on minimum amount of square footage or cubic feet of air that can serve a system. In order to calculate these actual volumes, they're going to give you some charts on the equipment of what the minimum square footage of the area needs to be. You'll see they are corrected for altitude. So, if we were looking at Denver, Colorado, for instance, you would be in this 4,000 to 6,000 feet of elevation. And if you had a system that held, for instance, 6 pounds of refrigerant, you would need that system to serve at least a minimum of 105 square feet of room space. As you can see, that's a pretty small area. That's just slightly larger than a 10 by 10 room. Most of the time, you're not going to have a ducted system serving an area that small, but it is something to be aware of just to keep yourself out of trouble. The factory charge will be printed on the data plate, just like it always has. You'll never go down, so for this system with 5 pounds 11 ounces, you would look at the 6-pound charge column. And here, as you can see, like we said, in Denver, Colorado, you'd be limited to no less than 105 square feet to install this system. The sensors. All of the A2L sensors are going to be installed in the equipment in the indoor coil. All the 454B sensors in Trane's equipment, for instance, will be the same sensor. They will have a plug on them, and it is a weatherproof plug. That sensor is going to come from the factory shipped for an upflow orientation. If you're doing a horizontal application, you'll need to move that sensor into the side drain pan. It simply clips onto the side. Best practice, because of shipping, it could become shaken loose, so make sure it's in the right place, no matter what orientation you're installing this in. Here's a photo of the application for the upflow on the left, and if you're moving it to a horizontal left, you would move that sensor over into that left drain pan. In the air handler, very similar. It comes factory installed for an upflow orientation, and if you're going to be installing it as a horizontal application, you'll need to move that sensor. The sensor is moisture resistant. Of course, if you're doing a coil cleaning or anything that's going to require a heavy amount of moisture of any kind, I'd recommend removing it just to not damage the sensor. The sensor's connector on that plug is a weatherproof connector. In the air handler, everything's going to be pre-wired because everything's already there. So you'll simply do your wiring just like you always have, and it should be factory connected in for the RDS board. The RDS board is the refrigerant distribution system. And as you can see on this 510 TEM6, it'll be on a hinge door that will fold out. On the external coils for gas furnaces, that RDS board will be located on the front of the coil. It can certainly be moved if you need to, and the only limit on how far you can move it is the length of those wires. There's also a 6-foot extension harness available if you need it so that you can mount it on a nearby wall. The RDS board, or mitigation board, is going to look similar to this. Trane is using two manufacturers to manufacture these boards in order to help prevent loss of stock due to any unforeseen circumstances or plant shutdowns. Let's take a trip around this board because this is where most of the confusion is going to come in. On the top of the board, we have two of the link connectors. This is Trane's new communication platform, and you can hook to either one or use them both, just like any other component in the link system. If you're doing a communicating system, that's the only connections you're going to need to make. If you're doing a 24-volt system, there'll be plenty of other connection options. An external switch. If you need to connect in a condensate pump or any normally closed dry switch, you can simply break this jumper and wire it in there. When this current is interrupted through that normally closed switch, it will shut down the compressor on the outdoor unit. You'll also have two accessory, normally closed contacts. These are going to open in the event of a fault. We may use these if we're having a non-communicating electronic air cleaner or any other accessories that we need to shut down if in the event of a mitigation. We have two spots where you can plug in the sensor. Initially, there was some thought that some of the larger units may actually require two sensors. However, that does not seem to be the case. So you can use either one, but if you do want to install a second sensor, you can use both. You would just need to simply remove or break that second sensor jumper. You're also going to have alarm contacts. Now, just the opposite of the accessory contacts, these are going to be normally open and they're going to close in the event that a refrigeration mitigation event is detected. Initially, they were considered making it to where you had to have an alarm, which is why they named them alarm contacts. However, that requirement actually went away. However, these normally open, close on a fault contacts will likely be used in some of the third-party things, such as zoning, where we would need to open up all of the system zones in order to maximize the area where we could mitigate that refrigerant into. We're going to have two status LEDs, a status and a communication. Just like any communicating device on the link system, that comm light is going to blink for each communicating component on that bus. The status LED will be green and indicate normal operation as well as faults. You're going to have two test pins where you can simulate a mitigation event. Simply jumper these two pins and it will simulate a mitigation event, opening the dry contacts for the accessories, closing the dry contacts for the alarm terminals, shutting down the outdoor compressor, turning on the indoor fan at cooling speed. You'll also have your 24-volt connections. You'll have three separate harnesses coming off this RDS board. One for the indoor unit, such as the furnace, one for the outdoor unit, and one for the thermostat. We'll look at that wiring a little more in depth shortly. As far as those lights goes, when they first power up, there will be a solid on period, basically a bulb check. If you're in 24-volt mode, your comm light will pretty much go off after that. If you are in communicating mode, it will blink once for each communicating device on that bus, like we spoke about. If you'd like to clear the alarm history, within 5 seconds of power up, you can jumper those two test pins and hold it there. It will clear the history. Although the history is only going to be retained on the train boards for 30 days, at which point it will fall out of memory. That's nice. You won't be chasing ghosts from last year potentially. If it's connected to a link system, you may see some other alerts appear in the event of a mitigation event. And those will be the 200 series errors that you might find on the thermostat. This is the field wiring diagram that's going to come with the indoor coils in reference to the mitigation board or the RDS board. Let's take a closer look at these. Now, with it being an electronic board, obviously you have to power it with low voltage, R and BC common. And that R and BC common is going to go out the other side onto your thermostat. We also have a GI terminal or G indoor unit. This is going to connect G to your G of your furnace to the GI of the RDS board. And then of course G is going to go to G of the thermostat so that you can control that fan mode from the stat. YI, Y indoor unit, is going to trigger that fan to run at cooling speed in conjunction with there being a call at G. Y1 is going to connect from the RDS board to your thermostat, just as it always has. Y out is actually going to turn off power to the compressor. So it's important that you use the YO for the Y outdoor unit and YI for the Y of the indoor unit. You'll also notice there are things like your BK wire. Now this is for blower speed control on a train furnace that is enabled with BK abilities. If that wire is there on both your furnace and your thermostat, you need to wire that BKI to the indoor unit and BK to the BK enabled thermostat. But if you don't have one of those, don't worry about it. You'll just leave that wire capped as you would for any non-used wire. W1 and W2, you'll notice, go straight from the thermostat to the furnace board. So you'll see the RDS board does not interrupt indoor heat, and it doesn't need to. So if you ever come across a no heat situation, it's probably not the RDS board causing it. You also have Y2. Well, this would be a second stage compressor speed. Again, we do not need to interrupt this signal with the RDS board. Nor our O wire, which is simply our reversing valve for heat pump systems. So again, that will not be landing on our RDS board. As we mentioned earlier, with our air handlers, that RDS or mitigation board is already going to be factory wired in, and your wiring is going to land just like it always has, between your thermostat, your air handler, and your outdoor unit. So, just like always, we had R in common. We had our O wire, G, our Y1, Y out from the air handler going to our outdoor unit. Make sure you're utilizing that terminal and not just landing on the Y1 of the indoor unit, or you'll inhibit its ability to shut off that compressor in the event of a mitigation or other sensor errors. We also have our Y2, our W1 and W2, and our X2 black wire coming from our heat pump back to our indoor unit. This is no different than the wiring has been to this day and shouldn't present any challenges for you. In regards to our electronic air cleaners that are in the airstream and could potentially be exposed to that slightly flammable refrigerant mixture, we do need to disable those. So for something like a train clean effects, we would simply interrupt our hot wire from our transformer going to R of that air cleaner by using one of those normally closed dry contacts on our RDS board. For other manufacturers such as ADP, they have a flex coil. Their RDS system is going to work very similar to what Trains does. Same as we've always had, we don't want to use the ADP coil on a heat pump for ratings issues. With the RDS system here, though, you'll see that the common and Y1 from the thermostat to the RDS board ties immediately in, just like a wire nut, to our outdoor unit. So in order to interrupt those signals, we actually have to interrupt R going to our thermostat. Now, a little different than the other system we just looked at, this would prohibit indoor heat from being able to be run in the event a mitigation event is triggered. Eventually, all mechanical equipment will fail and need to be replaced. When that day comes, you need to write on the outdoor equipment that the refrigerant was recovered, write down the dealer name and the date that it was recovered. If you do have any questions, don't hesitate to reach out to your local service advisor with G.A. Larson. We'll do everything we can to answer any questions you may have. But hopefully after watching this presentation, you feel a little more confident and a little more at ease with that slightly flammable rating. In all honesty, we've had a lot more flammable things in homes, such as natural gas running through our pipes or propane running through pipes, and we've not had all these regulations. There are a few more regulations nowadays with these slightly flammable refrigerants, but with good refrigerant practices, it should be raised little concern for you. Thank you.